Hello again, this is Nick Lodato, and today is the eighth part of the Creating Accessible Documents in Word series, this one on using color. Now, what we want to talk about today are some of the issues in color, namely color blindness, and really as a second part of the last episode on contrast specifically regarding color. And we'll talk about how to measure that contrast and some tools for determining the contrast ratio. So first, a few ideas. The idea of color blindness, there are several different forms of color blindness. This graphic shows at the top what the spectrum looks like to a person with normal vision, and 92% of the population has normal vision. A very small fraction at the bottom of the chart uh, have total color blindness, chromatopsia. And as you can see, relatively small percentages have different forms of color blindness that affect particular colors. Not, well, in total, 8% of the population is affected in some way by color blindness. This is a common test for color perceptions called the Ishihara Test. And what the test shows is in the upper left-hand corner, what this array of dots would look like to a person with normal vision. So it's pretty easy to see the numeral 2 displayed in the graphic. But as you look at the other forms of color blindness, filtered so that the image appears as it would to a person with that color blindness, you'll see that for the protanope simulation in the lower left-hand corner, it's very difficult to perceive the numeral 2 in the image. So you see the different flavors of impact that color blindness can have. Also wanted to give another picture of those same four conditions: the normal color vision, the blue blindness, red blindness, and green blindness, in terms of what a particular image would look like if you had that affliction. And finally, just to mention that people have done research into what colors are safe to use, that is, will not create problems with someone who is colorblind. These are colors that that work for most people. Now let's get to a hands-on portion. So here we have a document, as we've looked at Word documents before, that talks a little bit about color. First, a refresher that the Web Content Accessibility, WCAG guidelines, and remember there are three levels. There's A, AA, and AAA. So these are the AA that are most commonly adhered to standards. AAA is the most severe standards in terms of the requirements. AA standard at the 2.1 level says that you need to get a contrast ratio of at least 4.5 to 1 for normal text. Now this document is depicted in normal text. It's 12 point. Large text is defined as 14 point bold or 18 point regular. So here's an example of normal text in 12 point Callisto MT and of large text in 14 point bold. Now, how do you figure out this color contrast ratio? Well, there are tools, and WebAIM, web accessibility in mind, from Utah State University has provided a tool, which we'll look at in a second, to calculate the contrast ratio. And we'll do that in a minute in terms of the hands-on. But here are some examples where the background text is white, and here are the codes in RGB codes in both numeric and hexadecimal format for white. So this is a white background and yellow characters. And you can see that even the 14-point bold, which is considered large text, it's very difficult to see the yellow on white. As a matter of fact, technically, cyan on white, green on white, and even this magenta on white all fail normal, and the others fail even the large. So here we have in the 14-point bold under magenta, the first to pass the test, the color contrast test for large text. The red text passes again the large text, but barely fails the normal text. I personally don't have a problem seeing either of those, but here we have the blue, which passes both, and obviously black. Black gives us the best contrast ratio, 21:1. The blue contrast ratio at 8.59:1 passes normal and large. Now to look at the same examples against a black background. So here we have white text on black background, and that gives us the same contrast ratio as black text on white background. So it's not surprising that they pass both normal and large. Yellow, which failed against a white background, passes very nicely, almost as good as white, the normal and large at a 19.55:1 ratio. Cyan passes, green passes, magenta passes, and red passes. Now red surprises me a little bit because sometimes I have difficulty personally with red on black background. This is big enough that that doesn't bother me. But when we get to blue, which was the first one to pass both normal and large against a white background, blue fails against a black background. And of course, black on black would be indistinguishable for anyone. And again, in a second, we'll get to how to make those calculations, but a few more notes about color. You do have to be careful when using color. Not only because some people can't see the distinctions in color, but also because the color combinations that you get may be distracting or irritating to some people as well. So here's the sort of the prime rule in terms of accessibility, is to never use color alone to distinguish things. So for instance, in this example in the boxed text, the text says, here's how to determine who's on what team by the shade of font that their name is written in. And again, some people will have trouble with that, and that's not the pure yellow, that's a shade of yellow, almost orange, but that still was going to fail accessibility tests. As a matter of fact, all of those colors in that box, the yellow of Alfred, the red of Barbara, and the shade of blue of Fred, they all failed the contrast ratio test. The red is 3.99:1, which is good for large fonts, but not for normal fonts. The shade of blue is 2.47:1, which fails both, and the gold is 1.69:1. Again, a failure. So it's important not to have that be the only characteristic that discriminates between things, because some people will not be able to see that distinction. The last topic here is more of an aesthetic topic. Sometimes when you use opposite colors or vibrating colors, you create visual problems for people with normal vision as well. Again, distracting. These are sometimes called circus colors. Red on green is a good example. The bottom red on green is pure red and pure green. And the top is a sort of standard shade of green, which is a little darker, and perhaps, well, better or worse, you decide. I find both of these as kind of objectionable. Well, now let's look at the tool for determining contrast. So here we have the WebAIM site, web accessibility in mind. And it offers and the URL is shown in a second in the summary. It offers this contrast checker. So to use the contrast checker, one plugs in the code for a color. For instance, we'll go with, I think this is pure red. Nope, that's pure green. My purity. This shows green against a white background. And you can see that that's given a failure. Now I have this thing blown up, and that's why you can probably see this easily, and you wonder what the big deal is. But in normal size text, this green, pure green on pure white is a problem. Now notice that if we switch the background to black, it passes because there is enough contrast there. This tool lets you actually sort of create your own colors by dragging and lightening the background to the point where, well, let's see the minimum place where they both pass. There we go. So at a 7.55 ratio, everything passes. And let's just look at the double A. Well, at this rate, the 4.18, the double A passes for large text, but still fails for small text. So you can use this tool to determine whether or not the colors that you are selecting actually work. Now, by the way, there's also the test here for graphical objects as part of the user interface. So for instance, a text box or a graphic component of a photo or an illustration. And one last thing before we stop the hands-on, would also show you a color picker. So this is a web-based color picker. It's a plug-in to my browser here. There are also color pickers that are available within Word and PowerPoint for that matter. And there are plugins for Windows and Macintosh that will actually run on anything against your background. So this particular one shows you in the box to the right, the box is the color that is selected currently, and it gives you all of the codes so that you can plug them into the color checker. So this is one example of a color picker called Eyedropper, so that we can actually look at a color, pick the color from a web page, and move through and pick that green and see in the lower right hand corner the code for that green. Okay, so now let's return. So in summary, WCAG specifications for version 2.1 AA version tells you that you need to find a contrast ratio of 4.5 to 1 for normal text, that you can go down to less contrast, 3 to 1 for large text and for images. Large text being defined as anything 14 point bold or bolder or larger. The WebAIM color contrast calculator is available at this address, webaim.org/resources/contrast checker. And color picker software can be obtained as a plugin for your browser or from the Microsoft Store if you're a Microsoft user. That's all we have for today. Hope you've enjoyed this, and until next time.